There we are. Okay, so what I want to talk about is moles. I want to talk about, what science in terms of chemistry and physics are. My conversation is going to be relatively deep. The reason is there are two aspects. One is understanding what we're doing and why we're doing it. The other one is what is it? What is physics and what is problem solving? And one is a very abstract idea. And what I mean by an abstract idea, you might hear it 10 times and you might not click. You might hear it once and you might click. This is for everything. Some of you will pick certain things up very quickly, and those same people will pick up other things slowly. We are all different and our brains are wired differently. And one of the bad things about science is it has a very bad reputation for being tough. What it doesn't have is a true reputation of what science is. It's a language and an idea, and it takes time for anybody to understand it. People like me might make it sound easy that, I can do it pretty quickly. The only reason is, as a language, I've been speaking it for 40 years. Obviously, I can speak it. You guys are just getting round to doing science proper. So, for that reason, I really want to talk about certain things, about moles, about a really amazing scientist called Avogadro. And the best thing about teaching online is I can go, hey, look, here's an image of Avogadro. Avogadro was awesome. So, the things we're going to do today in terms of a lesson, okay, we are, just bear with me a second, just bear with me one tick, there we go. Um, Annie, that's far too loud. Can you give me 5 minutes? So, what are moles? So, when I'm teaching now, year 10, year 11, year 12, the sentence I write on top of every lesson I teach, everything is twofold. First thing, um, mass is always in grams in chemistry. This is not true of physics. Physics mass is always kilograms. In chemistry, it's always grams. Okay. The second thing that I write is you can only compare moles, not masses. Okay. And this is really important. These two things are very, very, very important. For you young ones, and I actually teach moles to year 7, the formula that you need is to calculate moles, you need mass divided by relative molecular mass, MR, okay? Or relative formula mass, whatever you want to call it, has different names. And that is literally the extent of the first step. So what I've done is two things to ensure that we're all on the same page. And as I said, some people will pick up certain things faster than others. I'm the same. There's some things I'm going to pick up faster than you guys. Some things you guys are going to pick up faster than me. All right. So how do we calculate moles? So here's a really nice sheet. Moles, and the first one we look at water, H2O. How many moles in 54 grams of water? Rule number 1, underline your keywords. I go blue in the face speaking about this. How many moles in 54 grams of water? Every question is in grams. I left it that way so it's nice and easy. Okay? I expect to see the following things. Your formula, right? Moles equals, oopsie, that's a minus, equals mass divided by MR. That's your first step. Your second step, exactly like physics, substitute your numbers in. Moles equals, mass is always in grams. They've given it to me, 54. Divided by its MR, 18. Pop that in your calculator. Well, press T. So number of moles equals 3. Okay. So that's question 1 done. That's how I expect you to lay it out. And by now, that should be really straightforward. Once you get to this, what is interesting is, what is a mole? There's a real technical explanation of what a mole is. It is the number of atoms compared to exactly 12 grams of carbon 12 isotope but I don't care. All right? That is something you need to know when you're 18, not now. 17, 16, 17, not now. But what is a mole? Why use a mole? That's the question. So after you do this sheet, and there's another sheet, the other sheet that some of you finished or some of you've started is this one here. I'll pop that sheet over there. Okay. And I'm going to tell you one thing. And we may do some work on it today, we may not, but it really doesn't matter. But I really want to talk about this because I think it's amazing. Now, and I'm going to put it in a way that is hopefully quite clear to year 9. A mole. 1 mole of any substance, for example, we just looked at water, right, e.g. water. Let's put that in brackets. E.g. water. E.g. water. I like that. I don't know how I managed to press that simple. Has the same number of particles as 1 mole of any other substance. E.g., I'll pick something nice. Silver. I like the colour silver. If you have 1 mole of silver and 1 mole of water, they both contain exactly the same number of particles. And that number is brilliant. It was worked out in an experiment by a really cool dude, right? Avogadro, all right? To give you an idea of how long ago Avogadro worked this out, this, young ones, is a picture of Avogadro. That's him. Italian dude who worked this out. And for me, the most amazing thing is not that he worked this out, and I'm going to tell you what the number is, I will tell you in a second, is the fact that Avogadro, oh God, when was Avogadro born? I kind of forget, it was a long time ago. 1776, I had to Google that, I forgot. So 1776, Avogadro was born. Let me put that there. He worked this out in 1776. 200 years before I was born. Or as my children would say, Daddy, did you know him? So yeah, 200 years ago he worked out what this number was. How many particles, how many molecules, how many atoms do you have in 1 mole or something? And it was amazing. He works it out to be 6.022 times 10 to the power of 23. Now, you don't need to know that yet. And I do say yet. By the time you finish this academic year, which isn't long, I expect year 10 to know this. There it is, the Avogadro constant. To round it up, that is 6, followed by 23 zeros. So 1 mole of anything has that many atoms, molecules, particles, whichever word you want to use, it depends on what you're looking at. All right? So what we're going to do today, we're going to calculate moles here. You've got to lay it out like that. This is a bit naughty. I'm not going to tell you why. You've got to be wide awake and focused, year 9, on this because, well, I'm just mean and horrible and I like to be mean and horrible. And then maybe if we've got time, this session we'll work with Avogadro. All right, so, oh dear, look at that. Let me just get my stuff here, move it down. Take that, move that down, take this. Yeah, you've already got some of this work we already started last time, all right? So I want you to do the first sheet. It doesn't matter how easy you found the work last week. I want you to do the first sheet, which is this one, just to refresh your brain, darlings. I'd like it laid out properly. Okie dokie. Let's stop the recording.